Hey everyone, I briefly touched on the packet processing last video, but just wanted to go a bit deeper on that today. I think the best place to start would be at the login screen. So we're assuming that the user has already signed up at the website of our in-game and are ready to go. Once the user enters their details and clicks login, we kick off the authentication process. So on login button pressed, save a bit of config, and then we jump into the auth network. So the first thing we need to do is open a connection to the server. So here I'm using the StreamPeer TCP class to do that. So after opening the connection, I'm preparing a login packet here. And then I'll start watching the connection in the process. But a little side note. So you can see here the packet is a string. This is really inefficient. I've reworked the entire Realm networking not to do this. So just ignore that for now. But yeah, the auth network still uses this old method. I'll get to this sometime. So now I need to wait for the connection to be established before I try sending any data. So once it's connected, and if I still haven't sent the packet, I'll send the auth data over to the authentication server. And then we'll just start waiting for a response. So yeah, once again connected, and I'm just watching the TCP buffer until it gets any data in it. So once it's got some data, I pull out the message, and again, because it's a string, I have to pass the string. So I split it out, split the different parts out, and then just check if it's a success or a fail. So if it was a failure, I just show an error. If it was when it's successful, I pull out the data from the response, which is the account ID and an access token. So I store these in the game state, and then we jump over to the Realm network and open a connection over there. So there is a lot to go over here, but to get started, we'll just follow the authentication process. So opening the connection is pretty much the same as in the auth network. So we open the connection, wait for it to be established, and send an auth packet. The auth packet for the Realm network uses the access token that we got from the original authentication. This verifies who the user is that's connected to the server and limits certain data requests to data that only the user can access. So, for example, only list that user characters on the character select screen. Don't get all the characters. It sort of helps limit those requests to relevant data for the user. You might have noticed that I'm building the packet a little bit differently here. I'm using the custom class to build the packets, which essentially involves just pushing bytes into an array and sending that array of bytes to the server. So when building a packet, the first thing I do is I add an identifying byte, which I've called an opcode here. This helps the server and the client identify the packet type and very quickly decide how best to handle it. I've got a bit more on that later once we get into receiving packets. So the next lines you can see I'm pushing data into that array. So I'm putting an unsigned 32-bit integer with the account ID, and I'm using this put string helper to put the access token in. So the put string helper just first pushes a byte that has the size of the array of the string, and then puts all the data for the string, all the characters after that. So when you're reading it back, you can go, okay, I'm expecting a string, so read the size and then read the data. Just makes it a lot easier to pass. This send packet method compiles the packet using this get packet method, and then just puts the data over the TCP connection to the server. So this get packet method, the first thing it does is it starts a new array, pushes in the total size of the packet. So we got the total size of the contents of all the data plus 2. So the 2 bytes is for the unsigned 16-bit opcode, because an unsigned 16-bit number is 2 bytes. So the size is important because sometimes the entire packet may not be delivered in one hit. So you need to validate that all of the data for the next packet has arrived before trying to process it. And so having the size is helpful to determine if all the data is in the buffer or not. Following that, like I said, the opcode and then the data itself. That array gets returned, and we just wait for a response from the server then. Once the packet has been sent, we can start listening for a response. I should mention here that these server packets are operating on the same packet structure. So that'd be the size followed by the opcode and then followed by all the data. So you can see here I'm waiting for some bytes to arrive. I extract the first integer and set it as the size of the packet. If there are not enough bytes in the buffer, I skip processing and check again later for more data. If there are enough bytes, I extract the whole remainder of the packet from the buffer and start processing. So I load it into a new world packet class and retrieve the opcode. This next part is where a bit of magic happens, so I'll quickly talk about the opcode handlers. They're pretty straightforward. I'm making use of the funcref method to assign a reference to the function to a key in the dictionary. This means that if you know the opcode of your packet, you can very quickly find the function that handles it. Once I have the function, I can use this call func method and provide it with the world packet as a parameter. So in this case, we're assuming we have received an auth response packet. So we can go to the opcode handlers, look up the auth response opcode, and we can see that it's going to be handled by the handle auth response function. So the auth response packet is very simple. It just has a 1 or a 0 to indicate success or failure. If successful, we send off another packet requesting the character list. On receipt of the character list, we would loop over all the characters and put them into the game state ready to display on the character selection screen. I say we would loop over all the characters because I'm only currently choosing one character from the list to display just to keep things simple. After we have the character list, I can switch scenes to the character select scene. So this is basically how the entire networking continues to operate. Once selecting a character, another packet is sent that lets the server know which character I've selected, and it returns a response acknowledging that, and we start loading into the world. This is the same process for movement, chat, trading, etc. A world packet is built and we listen for data from the server. I hope this has been interesting for you guys. Let me know in the comments below. I have a Discord as well, and I'm always happy to answer any questions. You can find the link to that in the description.